All right, my calculus students, this is your lesson over section 3.1. We're going to be finding extrema today. Extreme calculus, derivatives to the maximum. First, to find extrema, we just need a little definition here. If f is defined over an interval, open or closed, then f of c is a minimum, that's just the y value. The y value at point C is a minimum if f of c is less than or equal to all the other f of x's in the interval. That's basically saying this y value is lower than all the other y values. Pretty simple, pretty straightforward. Same thing for a maximum. F of c is a maximum if f of c, or the y value, is greater than all the other y values in the interval. So if we look at these down here, there would be a this right here is bigger than a lot of the other ones, but it's not the actual maximum. On this one, the maximum actually occurs here. That's the maximum, and the minimum is right here. This is very important because the maximum or the minimum can happen at the endpoints. Some of you are going to forget that, and I'm going to yell at you, and Curious George might come over and hit you. I don't know. This function, however, we'll call this f, we'll call this g. G of x, though, well, the y value's here. This looks like the minimum right here, but there's no value actually there. So if it, even though this, maybe let's call this -2. We never actually reach -2, so that means -1.9 is the minimum? No, because it's just, we didn't quite reach it, so maybe it's -1.99. Well, it's no, because we can get a little bit closer there. -1.999? No, this one actually does not have a minimum. And the maximum right here, well, it looks like it'd be right there, but once again, we can never actually get up to that point, so this actually has no maximum at either. So what's the point of this? What's the point of looking for minimums and maximums if they don't necessarily exist? Well, we're going to use the extreme value theorem. The extreme value theorem will tell us if a function does have a minimum or a maximum. If f is continuous over a closed interval, it's a closed interval right there, so that means it's got to have two solid endpoints, kind of like this one right here. It's got two solid endpoints. Then f has a minimum and a maximum. This one right here had a minimum and a maximum. You'll notice this one right here, though, failed on two accounts. First, it is not continuous. It's not continuous, so it fails the first condition right there. And the second condition, being on a closed interval. Well, that's closed right there, but this endpoint right here is not closed. That's an open interval. So this one also fails the conditions for having a minimum and a maximum. So now, how do we find it? Well, once we do the quick test here using the extreme value theorem, we got to do a test. How can we tell once we know that there are minimums and maximums, what do we do next? Well, we're going to use this key point right here. This is a big idea. Very, very important. A function has relative extrema when f prime of x is equal to 0 or when f prime of x is undefined. One of those two. Just as a quick case here, if we have a simple parabola on a closed interval, here to here, it's going to have extrema, well, right there. The slope of the tangent line, the derivative, is going to be 0 right there. Now, how can it be undefined? Well, that's a good question. What if we use the most simple one we could possibly know? What about the absolute value function? Along here, the slope looks like it's -1. Over here, slope looks like it's +1. What's the slope right here? Well, there is no slope. F prime of x is undefined because there's multiple different tangents right there, so it's not doesn't actually have a derivative there. So if you want to find extrema, here are the steps. To find extrema, you're going to find all the critical points. To do that, you're going to do two things. You're going to find f prime of x. Then you're going to find when f prime of x is equal to 0 and find when f prime of x is undefined. Next, you're going to check the output at the endpoints and at the critical points. Those are the only two places where you can have a minimum or a maximum. The only two places, at the endpoints or at the critical points. It's not going to be anywhere else in between. So let's go ahead and do just a very, very simple example here. One thing I do want to make a note of here. If f is continuous over AB, then f has a minimum or a maximum. I would like to note that the maximum can occur at two different points. Same thing for the minimum. You may say to yourself, Mr. Kuhne, how can it have a maximum at two different points? Well, the maximum is just the y value. So, for example, on this one right here, this y value is 5, and this y value is 5. The maximum value is 5, and it does occur at two different points. That's okay. The minimum here only occurred at one point, but that's fine too. On this one, if we extended this just a little bit farther, the minimum could happen at two different points. That's all right. All right. Once again, just a very simple example here. We're going to find the extrema of f of x, where f of x is equal to 3x to the fourth minus 4x cubed over -1, 2. Oh, we'll make it plus 1. Sure, why not? So, got to check our two conditions. First, does it even have extrema? Should we even waste our time with this problem? Not waste our time, but should we even look for them? If f, well, is f continuous over a to b? Well, that's definitely a continuous function. Polynomials are continuous. So it's continuous, and is it a closed interval? Well, that is a closed interval as well, so we're good there. So, we've got to do two things. First, we're going to find all the critical points. So we're going to take f prime of x, and we're going to get 12x cubed minus 12x squared. The derivative of 1 is nothing. And we're going to find when this is 0 or undefined. When is f prime of x? Will this ever be undefined? Nope, nothing to worry about with this one. If we had some other functions like hyperbolas or rational functions, we might have to check those points. But this one, we don't have to check those because it's never going to be undefined. This one would have been undefined right here, but not for this one. And we're going to find when f prime of x is equal to 0. So when does 12x cubed minus 12x squared equals 0? Well, some quick factoring here. I'm going to factor out a 12x squared. And we're going to have an x minus 1 here. So that's going to happen when x is equal to 0 and when x is equal to 1. So, got that done. We're going to check the output. For the endpoints, don't forget those, and the critical points. Our two critical points are 0 and 1. So, I'm just going to make a little table here. X and f of x. And I'm going to check my endpoints. -1, my critical points, and my other endpoint. If you forget your endpoints, Curious George just might come over and hit you. don't forget your endpoints. So we're going to take these values and plug them back into the original to find out which one's going to be the minimum or the maximum. So let's try plugging in -1 here. -1 to the 4th power, and that's just 1 times 3. It's going to give me 3. Plug in -1 here. -1 plus 4 plus 1, and that's going to give me 8. Check my critical points. 0. If I plug in the 0, that's 1. That's an easy one to work with. Plug in 1. I'm going to get 3 minus 4 plus 1. And we're going to get 0 there. And let's plug in 2, the other endpoint. 2 raised to the 4th is going to be 16. We're going to have 48 minus. We're going to get 2 raised to the 3rd power, and that's going to give us 8 times 4, 32. And we're going to add 1 to that. And so we're going to get 15 here. So, where did the extrema occur on this? It would appear that, if I've done my math correctly, the extrema are going to be at 0 and 15. Maximum is going to be f of 2 is 15. The minimum is going to be f of 1, which is 0. And if you're doubting this at all, you can always use Desmos to graph this and actually look it up. Look up to find what, look it up, and if you limit the range from -2 to 1, and then just check those points, you would actually see the function actually starts, it's 4th root, so it's going to start coming down. So it's going to start 8, come down. 0, it's going to hit 1. And then at 1, it's going to hit 0, and then it actually starts going back up again. That's what the function would look like. If you get some, you might get some weird function that you don't like, that you're going to have a hard time finding 0. For example, let's say you had to find the maximum or minimum of, let's say it's a sound wave of let's give it some amplitude too here. 2x times sine of 3x. And we got to find critical points on 0 to 2 pi. Well, we would be doing the same. Oh, sorry about that. We'd be doing the same thing here if you had to find extrema. First thing we're going to do is take the derivative. And we're going to take the derivative here. Oh, got to use the product rule. The derivative of the first is going to be 2 times the second. Plus, the derivative of the second, derivative of sine, is going to be cosine 3x, chain rule, times 3 times the first. So I'm going to clean this up a little bit. And I'm going to get 6x times the cosine of 3x plus 2 times the sine of 3x. We got to find when this is 0 or undefined. This is never going to be undefined. Those are both continuous functions, so adding together will also be continuous. So I got to find when this is equal to 0. Now, you can go through some crazy process. There is a way to do this by hand. It's super exciting and super fun. However, at this point, you might just want to use your lightsaber. That's right, get out your graphing calculator and actually graph this function. Find when it equals 0 in the interval from 0 to 2 pi. Find the zeros using graph calculator lightsaber. Once you got those zeros between 0 and 2 pi, then once again just make your chart. X and f of x. So we're going to plug in 0, we're going to plug in 2 pi, and any critical points. So endpoint, endpoint, and all the critical points in between. Seriously, you can solve by hand. I would just graph it and use a graph calculator to find the zeros. Thanks for watching.